In terms of the methodology behind what we're going to go over today, this isn't something we just made up. This is a very common methodology, very standard methodology on some of the largest project management organizations. So if you look at PMI's process overviews, if you look at the AACE's process overviews, go to the UK and look at the APM. All of these guides have a very similar process. And a huge benefit of this Primavera risk tool, or the Oracle risk analysis tool, is you have the ability to take these risk events, items that you didn't plan for in the scope, you may have just in an Excel spreadsheet, and you don't even know if they're going to happen or not. Something like a contract delay or a permitting issue, things you didn't plan for, but if they happen, they're going to have an impact on your schedule. Generally speaking, these risks are held separately, and what this is going to allow us to do is tie those in and really make them a living, breathing part of the estimate or the schedule. So going through this, this is a methodology that's focused on by all of the major project management organizations. Just to give a couple key terms off the bat, one is Monte Carlo analysis. You'll hear the buzzword Monte Carlo analysis all the time. All a Monte Carlo analysis is a probabilistic simulation. It's something that we do and run over and over and over so we can see a trend curve develop. So if anybody goes on like an ESPN.com, they simulate basketball games or football games. They put in a bunch of factors on the game and they run it over and over again until they can decide what they think the scores are going to be. You see it in funeral service companies will do a Monte Carlo on death rates based on various factors for that year. Insurance company have lots of historical data, and they're doing the same thing on death rates or car accident rates. They run these simulations over and over again, and based on running this probabilistic information, the trend curve really should provide a view of reality. So we're taking that same concept and we're applying it to an estimate or a schedule. So we'll put some when we come up with our schedule, we may say, hey, we thought it was 20 days. We can put some variability around that then, and then when we run that simulation, we can really get a feel for what our schedule is going to do in realistic conditions. So all we're really trying to do is simulate reality. A word I may say quite a few times is a three-point estimate. A lot of times when we're looking at a single-point estimate, that would be what was in our schedule or what was in our estimate. We said it's going to be 20 days. That's a single-point estimate. It's a single value. That's our best guess. Often when we're looking at probabilistic information, we're looking at three-point estimates. So that would be a best case, your single point, your original estimate, and a worst case. So a minimum, a maximum, and a most likely estimate, which is very common for putting variability on, whether it's costs, man hours, durations, etc. So what we'll do is take some of these three-point estimates, we'll put them onto the schedule, and then we'll run a simulation where our bars move around, our costs change, and we'll be able to develop confidence levels of hitting certain schedule dates based on that probabilistic data running over and over again. So we'll see that trend curve develop, and the trend curve will be relative to our project schedule or our project estimate. The last buzzword I'll go over is a risk register. Seeing as though this is a risk demo, I'm sure a lot of you already realize what a risk register is. But all it is a list of risks, as much or as little information as you really want to track. The key, though, relative to doing a schedule risk analysis is when we bring something into a schedule, cost, probability, and duration can all hit the schedule. If you think about these risk events, items in a risk register really are activities in a schedule. They're just probabilistic, so they may happen or they may not. So when we model these risks in, they'll become a living schedule. They get converted into schedule activities, with the main difference is they have a probability of occurrence. So if I say, hey, you know, it's a 100-day risk item, that's going to hit the schedule somewhere. But when we run the simulations, maybe there's only a 10% chance that those risks occur. That's basically what we're doing. We're just scheduling. We're just putting in probabilistic values.